Have you ever wondered how structures like tunnels, bridges, and even cities are built underwater? Our world is filled with engineering marvels that stretch beyond the land we walk upon, reaching into the depths of our oceans and seas. Take, for instance, the Channel Tunnel, a 50-kilometre-long undersea passageway that connects England and France, or the Poseidon Undersea Resort, a luxury hotel situated 40 feet below the surface of the sea in Fiji. These are but two examples of the extraordinary feats achieved in underwater construction. However, building beneath the waves isn't a walk in the park. It poses unique challenges, from dealing with high pressure and unpredictable currents to ensuring the structure's durability against corrosion and aquatic life. Yet, through a blend of scientific knowledge, technological innovation, and sheer human determination, engineers continue to push the boundaries of what's possible. Intriguing, isn't it? Let's dive deeper into the world of underwater constructions. Engineering underwater is a marvel that tests the limits of human ingenuity. Picture this: the sea, with all its vastness and unpredictability, is our canvas. The undersea world is a realm where the usual rules of construction are flipped on their head, and we must not only adapt, but innovate. The American Society of Civil Engineers and the Journal of Waterway, Port, Coastal and Ocean Engineering provide extensive studies on the subject. They highlight the unique challenges posed by underwater construction, from the relentless pressure exerted by the ocean's depths to the corrosive effect of salt water and the constant threat of unpredictable weather and sea conditions. Yet it's these very challenges that make underwater engineering a testament to human creativity and resilience. Consider the principles of buoyancy and pressure, for instance. Engineers must calculate the exact amount of buoyancy needed for structures to resist the crushing pressure of water, while also ensuring stability against the ocean's currents. This delicate balance is a dance between physics and engineering, a dance choreographed in the depths of the sea. Then there's the matter of materials. Traditional construction materials like steel and concrete behave differently underwater, affected by factors such as corrosion and marine growth. Engineers have to delve into the realm of materials science, developing and utilizing materials that not only withstand the harsh oceanic environment, but also stand the test of time. And let's not forget about the human factor. Underwater construction is a high-risk endeavor, requiring stringent safety measures and protocols. It's a job that calls for courage, precision, and an unwavering commitment to safety. The marvel of engineering underwater, then, is a symphony of disciplines, from physics and material science to risk management and safety engineering. It's a testament to our capacity to dream, to innovate, and to build, even in the face of the most daunting challenges. Next, we delve into the actual process of building under the sea. Building underwater is a complex process involving a series of intricate steps. It's like a dance, choreographed with precision and expertise, where every move is vital to the outcome. Let's delve into the process of underwater construction, shall we? The first step is site selection. Engineers must consider a variety of factors such as water depth, seabed conditions, and environmental impact. This stage is critical, as the wrong choice can lead to catastrophic failures. It's a high-stakes game of strategy where the wrong move could cost millions. Next up is design. Crafting the blueprints for an underwater structure is an intricate task, involving countless calculations and simulations. Engineers refer to studies from the International Journal of Civil Engineering and the Journal of Construction Engineering and Management to ensure their designs are robust and sound. It's like piecing together a giant jigsaw puzzle, only this one will reside beneath the ocean's surface. The choice of materials is crucial. They must be resistant to corrosion, high pressure, and the harsh marine environment. Stainless steel, high-strength concrete, and special marine-grade alloys are often used. It's like choosing the right armor for a knight, where the wrong choice could lead to defeat. The construction methods used in underwater construction are fascinating. From cofferdams, which allow construction in a dry environment, to underwater concrete placement and the use of remotely operated vehicles, or ROVs. It's like building a castle in the middle of a storm, where every move must be calculated and precise. Finally, safety is paramount. Underwater construction is inherently risky, and measures to protect workers and the environment are vital. From specialized training to advanced equipment and strict regulations, every precaution is taken. It's like walking a tightrope over a canyon, where one misstep could be disastrous. Now that we understand the process, let's explore some cutting-edge techniques in underwater construction. It's like stepping into the future, where the impossible becomes possible. Today, engineers are using cutting-edge techniques to build underwater. In the depths of our oceans, far from the prying eyes of the public, an engineering revolution is taking place. The traditional methods of underwater construction are being replaced with more innovative and efficient techniques. One of these cutting-edge techniques involves the use of remotely operated vehicles, or ROVs. These sophisticated machines are capable of performing complex tasks at depths that would be prohibitive for human divers. Equipped with cameras and robotic arms, they're like the underwater equivalent of drones, carrying out inspections, repairs, and even construction tasks under the guidance of operators stationed safely on the surface. But it's not just about the machines. The materials used in underwater construction are evolving too. According to recent studies published in the Marine Technology Society journal, engineers are now using advanced materials that can resist the corrosive effects of salt water and withstand the immense pressures found at great depths. For instance, they're using carbon fiber reinforced polymers, a lightweight yet incredibly strong material, and self-healing concrete, which can automatically repair its own cracks, reducing the need for costly and dangerous underwater maintenance work. Furthermore, digital modeling and simulation technologies are playing an increasingly important role in underwater construction. These tools allow engineers to test their designs in a virtual environment before any construction begins, helping to identify potential problems and optimize the design for the unique challenges of the underwater environment. Also, the role of artificial intelligence in underwater construction cannot be overlooked. AI is being used to analyze data collected by ROVs and other sensors, helping to identify patterns and make predictions that can improve the efficiency and safety of underwater construction projects. The Journal of Ocean Engineering and Marine Energy has highlighted how these techniques are not only making underwater construction more feasible, but also more sustainable. By improving efficiency and reducing the need for human intervention, they're helping to minimize the environmental impact of these projects. These advanced techniques are pushing the boundaries of what's possible in underwater construction. With every passing day, the depths of our oceans are becoming less of a frontier and more of a new frontier for human innovation. So, what does the future hold for underwater construction? Delving into the vast expanse of the ocean, we find ourselves at the precipice of a new frontier. As we look towards the future, we see the potential for underwater cities, a concept once only found in science fiction. The Journal of Future Cities and Environment predicts that by the mid-21st century, we could see the first prototypes of these aquatic metropolises. However, building entire cities beneath the waves is not without challenges. The pressure, the corrosive salt water, and the sheer logistical complexity of constructing and maintaining structures on the ocean floor are all formidable hurdles to overcome. But with the rapid advancement in technology, these challenges are becoming increasingly surmountable. At the forefront of this field, the Journal of Ocean and Coastal Management has highlighted several promising technologies. One such technology is bioconcrete, a material that harnesses the power of bacteria to heal its own cracks, increasing its lifespan and reducing maintenance costs. Another is the development of advanced robotics and autonomous underwater vehicles. These machines could perform tasks that are too dangerous or impractical for human divers, such as welding at extreme depths or installing heavy components. But it's not just about the technology, it's also about the mindset. As we continue to explore the oceans and understand their importance to our planet's health, we must also consider the environmental impact of our underwater constructions. We need to ensure our future cities are sustainable, working in harmony with the marine ecosystem rather than against it. The future of underwater construction is not just about conquering the ocean depths, it's about learning to live with them, to respect them. It's about creating a future where humanity and the ocean can thrive together. And so, as we stand on the brink of this exciting new era, we are driven by the spirit of innovation and the promise of discovery. As we continue to push the boundaries of engineering, who knows what marvels of underwater construction the future will bring? So we've taken a deep dive into the world of underwater constructions. We've unraveled the mysteries, marveled at the engineering genius, and followed the intricate process of building beneath the waves. We've seen how engineers breathe life into the depths, constructing structures that defy the limitations of the terrestrial world. From the foundational principles of pressure and buoyancy to the advanced techniques like saturation diving and remotely operated vehicles, we've observed the evolution of underwater construction. We've also glimpsed into the future, where underwater cities and subaquatic transportation systems may no longer be the stuff of science fiction. We've seen how research and innovation continue to push the boundaries, transforming the oceanic abyss into a realm of limitless potential. In essence, underwater construction is a world where engineering and imagination intertwine, creating a testament to human ingenuity. As we've seen, underwater construction is a testament to human ingenuity and the boundless possibilities of engineering.